Center University. His past experience includes 12-year experience teaching in NIT Durgapur, about 1 year in NITTR Kolkata, and about 11 years in Government Engineering College in West Bengal. He has about 30 years of teaching research experience. His fields of research interest are computational biology, bioprocess controller, IoT and its applications. He is currently supervising 11 PhD scholars and mostly in IoT domain. He has published one book of international repute, holds one Indian patent, and has more than 65 publications in international journals and conferences. Welcome, Professor Gautam Saha. Sir, please, you can.
Yeah, I think 93 means sufficient numbers as accommodated.
Yeah, sure, sir, sure.
Yeah, thank you, sir. Welcome all of you back. Probably you have got short back now. Today my topic of discussion is architecting the IoT for real-time services support. I think the slides are visible to you, is that it?
Yes, sir.
Slides are
Yes, sir.
visible
Yes,
to
sir.
you,
Yes, sir.
and my voice is also clear.
Yes, sir.
Okay, so architecting the IoT for real-time services and support. So here I will try to focus on some. I like to encourage you for going into startup ventures using IoT, and which is not very costly. It is not at all very costly. Even if you have got 2 to 3 lakhs of rupees, you can at least start your venture. And if your college provides you the lab, which is costing you, if you want to set up the IoT lab, it will cost you not more than 2 to 3 lakhs of rupees. So if that type of lab is there in your universities or in your colleges, you can use that lab for making your prototype and at least start initiating the commercializations of the prototype models. And from there, you can start initiative to sell the products, to find the avenues where you will sell it. Not actually in any business, you first see where is the demand. First, you have to investigate where is the demand, and if you find there is some demand somewhere, some items are coming from outside, and you can replace it by our existing technology. So go for it, because definitely if you develop something, it will cost much less than the foreign countries. For example, I'm telling you, for example, this is an IoT device. Israel is selling one border, that means human intruder detection system, which are very good, which are giving immense support to our Indian military in the BSF, specifically in the Pak border. Not widely used in the Bangladesh border, which should have been used anyway. But this is giving. But one unit they used to cost 3 to 4 crores of rupees. One such unit, small units, very small units. Okay, and once when I was there in Israel, I had heard of it. Now but Israel is very much conservative country, and they will never tell you that what is the technology behind it. They will never. And they have, when I reached there, they have told me, this is your job, this is your lab. If you venture into some other lab and try to know what they are doing, we'll simply take you and we will push you out of the country. I will take you to the airport, and through the airport I will send you back to your country. So this is the first word they have told me after reaching over there. They are very much conservative in their business approach, business angle. Anyway, so later on I found that that means that its purpose is just to see whether some human being is coming or not. In the border, there are some jungle areas. There are a lot of animals are there. Maybe there are a lot of animals, a lot of other things are there. A lot of insects are there who are moving, living systems. But it has to detect only the human being. Okay. Now, for detection of the human being, after coming over here, I thought, why not to start venture into that. Specifically when I was colleges, I couldn't do anything. But when I reached Shillong, after 2 to 3 years, I started venturing into how they are detecting it. Actually, I found that they are detecting the human being by just sensing some electromagnetic radiations which are coming out from the human being. Every human being radiates. Every living human system radiates. Even after a human being, after he is died, he also radiates for 72 hours. Not he, I will say the dead body of the radiates for 72 hours. Of course, in the decaying mode, but radiates. So that's radiation pattern. This radiation pattern is different for different living systems. For cow, it is different. For fox, it is different. For lions, it is different. It's like that, like that. So they just detect the pattern of the human radiations. Maybe it is heat radiation, maybe it is some other radiations, and and after that, once there is some antenna into it. Nothing is there. Small elements, no camera, nothing is there. It has got 2 or 3 types of antennas are there, and some amplifiers are there, and so one DSP processor is there inside it, and just they analyze that particular real-time signal, and over there something they analyze over there. But if it finds it to be complicated, then it sends it to the cloud, and where they get the real analysis. And after that, when they confirm some human being is coming in this area, immediately they report it to the control room. And they are taking 3 crores of rupees over there. Now, we started doing it with Jadavpur in Signehu, and we developed the sensor. We developed the antenna. Initially, our antenna was too big, very big. It was very big in the sense it came around 1 foot, I think, yeah, it is 10 inches by 8 inches, like that. But what they have done, it is very small. It is maybe 3 inch by 3 inch, and this guise of a stone. Okay, 3 inch by 3 inch. But that means I have to go for microstrip antenna. So we developed that also with some research scholar. Though the research scholar has fled away, he was he didn't continue. So that project is also stopped. We did that, and we found that really it is giving, not only it is giving the human being interpretation, that if somebody is passing at least 5 foot away from the sensor, 5 to 6 foot away from the sensors, it can detect it. It can detect, not only detect, it can say whether it is a male or it is a female. Male and female detection is also possible. We have done it. I've seen it. When this real-time signal is, we do the Fourier transform, we found that for women, some particular frequency band is absent. For male, that is absent, present, always. And we are confirmed, and we have done it many times, and we found it, yes, it is one. So, now, actually, 5 to 6 feet is very less distance, smaller distance. So, for real-time application, commercial applications, it has to be at least 500 meters, or if it is more, it is better. So that means antennas, gain, and all these things has to be adjusted. All these things. Those things I have not done it till now. If I get a good student, I will again start it. And if I get collaboration from Jammu University, I will also start it. Okay. So anyway, that is different issue altogether. I tell so many things during my lecture. Don't mind it. So what happens? So I found that if I make the whole system, including the DSP chip and everything, it doesn't cost more than 25,000 rupees. Max to max. I am telling you, max to max. 25,000 rupees. Maximum. I'm not talking about the material cost. I'm talking about including my students' fellowship. Whatever the cost is coming, it's 25,000 rupees. And they are selling it at the rate 3 crores of rupees. So you can understand what is called business. You have to understand that they are in a constant threat. They are always in a constant threat. So their border with the Gaza, the nearby their another hostile, extremely hostile states, they are always has to guard it like anything. And human guarding means it will cost human being. So the human being is very precious for them. If somebody is dying, they will try to their best so that it is not like India. Somebody is dying, let him die. Not like that. In India, the corona deaths are counted by numbers, but there they count it by in real-time basis, by human being. They cannot afford to lose human being because they have to fight all the time. Anyway, so that is they use many instruments and they plant it in their borders, and they are very much successful over there. So this is the business. This is the IoT business which you can support on. So you can think of real time. Another is American soldiers. you will find when the American soldiers go to the battlefield, specifically who are in the. Achha, my slide is. I'm not shifting my slide. Okay, don't worry. I'll shift my slide. It is working. Okay. Is it okay? Changing, na?
Yes, sir. Yes, sir.
Changing. Okay, nice. So I have not changed my slide. So what happens, what I'm telling is in this way. You see that they are highly gadgeted throughout their body. The lot of gadgets are there. Lot of gadgets. Basically, what I understand, many modes are there. MOT, yes, and the last lecture I have told about the instruments which are computational instruments which are used by IoT. I told you Galileo is one of them, Raspberry Pi is very important one of them, modes is another thing. A lot of modes are there in their body, whole body systems. So when a soldier goes into action, they don't have so many soldiers. They will not employ in India or say in any, I will not name any country, in some other country where human being is not a problem. They will send 100 soldiers in one particular place where Americans will send only not more than 10 soldiers. How they are working them? Actually, they can see, they are informed, and their body parameters are always monitored by the external by the control room. Okay, and they are constantly monitored by the control room, and they are constantly monitored otherwise also through cloud. And if somewhere they feel that there is some problem, it is some dangerous area, they will be outnumbered very soon. They will be informed well ahead, and so that they can shift themselves from the area and take some other area. They will inform their command that send some drone or somebody to bomb this area. So they are highly mechanized warfare. It is a highly mechanized, and electronic warfare is very, 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 very strong, which we cannot think of. So those are the areas. Even when they aim at killing some soldiers, enemies, or neutralizing, I will not say the killing, I will say neutralizing enemies. Their guns are also their guns are also they can aim their gun accordingly as per the signal, real-time IoT signals, that here is the enemy. He cannot see, but his gun is automatically shifted in that direction for firing, so that the fire can go and penetrate, neutralize the enemy instantaneously. Though the soldier who is firing, he cannot see him. He doesn't see him at all. Nighttime vision is always there. Each soldier is connected to each soldier through their modes, because they are IoT connected, hopping systems are there. So this is when a group of soldiers is moving, means an ad hoc network is also moving. Okay, so how these things can be designed real-time basis, how these things can be designed on real-time basis, it will give you a lot of money. If you can do it, it will give you good startup initiative, very good startup initiatives. Though personally, I'm not in favor of war or anything else like that, because killing a person is not good. But we have to protect ourselves. If we are attacked, we have to protect ourselves. Up to that level, we have to be prepared. So anyway, so this is this architecting IoT for real-time services. This has got great role on the defense field. The future war will be IoT-based war. The future war field will be IoT-based war. Planes, nobody will go on the plane. The drones will be the basic instrument for firing missiles and everything, and they will be controlled remotely by the satellite systems or by the moving soldiers whose purpose is not to fight, just to get the infrared pictures of the surroundings and find out the strategy from the cloud. Strategy will be decided by they are moving and moving on the ground, they're moving on the foot, and it is sensing so many things near about by infrared ray or something, and those things are going in the in the cloud, analyzing and chalking out the strategy, where to attack, how to attack, and what things will happen, one, and which soldier is wounded, immediately he has to be taken care of, which group is endangered, and how to warn them early so that they can human loss is minimized. Thousands of soldiers died is not the strategy of USA, neither any great country, in one battlefield. They will definitely afford 1, 2, up to 10 maximum. They cannot afford more than that. This is only possible to use the IoT-based warfare. Okay. Now, this is very nice to hear. This is nice to imagine. Yeah, that I will make a startup business, IoT-based startup business, and I will supply a huge amount of items to defense, and I will earn huge amount of money. But how to make it? That is the issue. That is the main issue. How to develop it and how to make it is the main issue. Now, in the introduction of IoT, I told you about the IoT architecture. For developing any IoT systems, for developing any IoT-based system, the architecture is different for different systems. At this present time, I am interested. I have not developed yet, but I am thinking of making aquaculture systems IoT-based. IoT-based aquaculture systems, because Bengal people are very much fish loving, and the whole aquaculture cultivation, the still cultivation system is highly dependent on the human expertise. That means there are some persons who can feel from their fourth sense that this I have to do it now, I have to do that now, I want to automate it, and so that the fish production in Bengal increases. So that is my at this moment I'm thinking of that. I don't know how far I will get support from that, but definitely I want good students with me, which I'm not getting over here. So if I can get somebody from outside, that would be so good. Okay, next. So now, first of all, what I am doing when I am fixing up my aim that I will make this, I will make that, I will make this thing for the military. First thing which we have to develop is the architecture. First thing you have to think of is the architecture. Next thing, after developing the architecture, then you have to think what are the drawbacks you are encountering in that particular architecture. What are the drawbacks are there you are facing, that architecture will face, and there are certain drawbacks which we cannot afford. We cannot afford. Say you are developing a medical system. Any failure of any sensor is unaffordable. If you are using any sensor, any instruments, its failure is a must. It will fail. If any instruments you are using, instruments must fail. There is no alternative. But you have to detect it. And if your IoT systems fail somewhere, possible. You are using machine, means machine must fail. You have to give that opportunity to failure. You have to find out reliability aspect. You have to increase the reliability. That means you have to find out some ways and means, so that if one instrument, two instrument fails, other it can get through. It can walk through other means, so that at least before the repairing is done, no casualty happens. No casualty happens. My first life was started with the medical instrumentations in Philips, India. I was there in Europe for a long time with in Eindhoven, and in Eindhoven means Philips headquarters in Europe, in Holland. So there they used to make some machine for which is used for open heart lung operation. So I was used to assist the doctors in the hospital for initiating or for operating that particular machine. Why engineer was going into the why engineer was engaged with the doctors in a operation theater? Because I know if the machine, that means while carrying out the operations, if any of the instruments fail or any load shedding occurs, if something happens, I have to switch on the second option within milliseconds. Within milliseconds, that has to take care. I have to see that. Otherwise, the patient will die. Patient on the table will die. That's why I was entering into that space. I means a non-engineer was entering into the spot. You cannot afford to make a fault while in action. So that is also one aspect you have to see, reliability. Somewhere, of course, when you are in that particular area. So there are several constraints. There are several you have to meet up. You cannot commit any mistake over there. When you are IoTization of the railways, you have to see that you cannot afford that two trains will collide face to face. How the two trains can collide face to face? Signal mishandling, maybe unintentional. In manual systems, it can happen, but it can happen by the enemies also. And this happened during after this Kargil war. And in West Bengal, the whole regiment, the Naga regiment, was eliminated, who were coming by train, and it was intentionally a huge amount of accident occurred in that face-to-face accidents of the two accidents. You cannot avoid, you cannot do it. So you have to see, while you designing certain constants, it cannot happen. So this is first thing which you have to think of first. So after looking into all these things, you have to design first the architecture. Then you have to find the faults of the architecture. You have to incorporate that properties into the architecture so that those things can be taken care of. And after that, you can work with that means and after that, what you will do? After that, what you will do? Then after that, you have to see. I'm telling you, since we are the engineers who do only mathematics, who doesn't have any real-time experience how actually engineering things are developed in the field. See, if you think something, if you design something in your pen and paper, and if you go to one company.
Sir, can you unmute yourself? Gautam sir, kindly unmute yourself. Yes,
Hey,
thank
how
you.
long I was muted? How long I was muted?
So just a fraction of seconds. Actually, I just muted all the participants because some of them was turning on their mic.
Okay.
Thank you.
Okay. Okay, but I think the things are going fine, no? No problem, no? You can hear me and see me.
Yes, sir. Yes, sir.
Okay. So what I told you is that if you design something on pen and paper, and if you go to a company and tell them, please give me money, I will purchase these instruments and I will make something for you, company will just throw you out. They will not spend a single naira because business is business. Until unless they are this company people, CEO companies, CEO, they are confident by some means that your things will work. They will not spend a single naira. They may have 1 lakh crores of rupees in their bank. You are wanting 10 lakhs only, but they will not give you that also, because business is business. So what is to do? You have to simulate. So you have to simulate. Simulate means whatever you are thinking, you have to carry it to some platform where you can do the simulation. Simulation means not mathematical. Sometimes it's mathematical simulation, but in this case, in IoT, there are simulation tools like Contaki-based Kuja is a simulation tool. Then there are some other open ways which I think that boy, my student, Noor has given you some presentations about the simulation tools. There are various simulation tools available. So you have to use a suitable simulation tool to see whether your system is working with open source softwares. If you then you have to get after that you just perform your things, you perform your aims in simulation and note down what is the QoS, quality of services, what is the performance levels, what is your RTT. RTT means round trip time, what is your latency, what is your throughput, everything, what is the that means packet loss, packet drop happening, everything you simulate. And after simulation, after simulation on computers, then you go for semi-simulations. That means something is there in the simulator, and others, that means sensors are disconnected, disjoint from there. Real sensors are given and disconnected to your system, simulators. So you have to go simulate for 2 to 3 steps. After sensors is one side, it is different. It is just sending signals, real-time signals to your computer, and the computer is simulating the whole environment. After that, what you will do, sensors plus switches, you bring some gateways, I would say gateways, give it to some other people. So in this way, you have to gradually, shift yourself from I will say, from this complete simulation to semi-complete simulations. After you do the semi-complete simulations, then you go for the desktop mode, that means small desktop models. And after that, the results, you publish a paper. And using those, you publish a paper, or you go for a patenting, etc., etc. Then you go to your, if your paper is published, if your paper is accepted, with your paper, with your patent, this patent applications and everything, you go to, if you get a patent also is nice. There are many patent organizations from in Australia where you can get patents within 3 months or 4 months, even 6 months. After that, you can go approach the companies. See, this is what we have done. This is the recognition that what you have done is achievable and it is okay. Then the company will give you money. Okay, go carry on. Go ahead. I'm giving you money. They will come. Then they will love you. They will really love you at that time. They will give you a lot of money for carrying out commercialization. That comes the hell of it. Here comes commercializations will give you a hell of a problem. What hell of a problem? My aim was railway IoTization. I have told you in the last day. So when I have installed the sensors in the engine and the other receiver in the signal in the signal stand, all the railways rail lines are, there is a signal unit, signaling unit one there after 1 kilometer like that. In the signaling unit there is no problem, but when the train is moving under that particular warhead wire, and specifically if it is a railway, if it is a electric engine, 99% engines are in railways are electric engines. There is a huge electrical noise because between the pantograph and the wire there is a friction, and sparks comes out all the time. This sparks generates huge amount of electromagnetic waves. It spoils your signals, just destroys your signals sometimes also. Okay. And you can repair your signals inside if you know the most of the noises are low signal noise, 50 hertz or less, like that you can destroy it. But when you are transmitting those signals, the train is moving, you are transmitting the signals toward the signal post. Again, that particular electromagnetic wave will destroy it. That you cannot save it. So you have to go for how to save your signals, how to save that means how to transmit the signals in the noisy environment. It was not there when you were simulating everything on the simulation, on the desktop, on the benchtop, whatever you say. This factor was not there, but it is coming now. It is giving you a hell of a problem. So how would save it? So you have to go for coding, ITC, coding cube, how to solve it by through coding. Our mobile phone, you know it very well. Our mobile phone has got only 5 milliwatt microphone, but I am transmitting the signal to the nearest tower, which may be 500 meters away. So the most of the signals are faded or corrupted. So how they are retrieved? In this technology, you have to incorporate. This technology you have to incorporate there, and that is a hell of a problem. That is a big problem. And you have to generate some suitable ITC code for that. So this is another one. Okay. So that means after that, when you are go for commercializations, you will find a lot of impossible problems comes over your head, and you have to solve them. You have to solve them comfortably, as many as possible. Some of them, yes, otherwise nobody will touch your, nobody will take your things at all. You cannot sell your products. This is called commercialization. This is called real-time utilizations of your products. So anyway, so I hope I have given you certain glimpse for startup units. Startup units means first you think what you are making. Second, you make the architecture. Third, you go for simulation on the software. Then you go for semi-simulations, software and hardware joints. Then you go for benchtop model development. After benchtop model development, you go for commercializations. In the commercializations, it will take 2 to 3 years, sometimes 5 years also it takes. For one case, I have developed something which took me 3 years to solve. Okay, so if you can solve it, that means if you want to make something for defense, what they will do? They will take your instrument, they will put it in the boiling water, and it has to work from there also. They will take your instrument, they will put under jerking conditions. Okay, 3G jerking. They will take your instrument, a tank will pass over that, but instrument still should work. They will take an instrument, they will put it in an armor vehicle, still it should be work. And each and everywhere you will find Himalayan problems, and it will be another research field. So commercializations will give you a lot of pain, commercializations, a lot of knowledge, and that means it is unbearable problems. But when you solve it, you will feel so happy. When you solve it, you will feel pleasure, a divine pleasure, I would say. Okay, so this is the things. Anyway, so I think I'm speaking so many odd things, but let me come into the pictures now. Let me show you one paper. I have told you that this paper I'll be sharing. This is the paper which I will be sharing with. This is the paper which I will be sharing with Lalit sir, and I think you can get this paper because I was basically a genetic engineer, bioprocess engineer, biological engineer. I have got patents also over there. I have got books out there. But this is basically pharmaceutical type of works. I have developed bioreactors and bioprocess controllers. But after that, when I entered deep into the biosystems, I found that everything is simulation and practical implementation commercialization is impossible. That's why I left that field. And when I was searching that area, this paper I have gone through from first paper page to last page, and it has given me I found it so interesting that I totally forgotten that particular genetic engineering, and not forgotten. I am not doing that area, but at least I have taken 4 research scholars who has already got PhD, one with 3 IEEE transactions, 2 patents, 1 patent, and 1 book he is writing, and another has got 4 SCI index journals, and that genetic engineering area. Another 2 is still there. Okay, these 2 are remaining on the genetic engineering. Others, everybody, all of them are working in the IoT domain, because I think here I can make something which, after retirement, I can do some startup business, and which can give me pleasure as well as money. So this is the paper you should go through. This is an outstanding paper. 2015, don't worry, 2015 is and 2016 where I started this particular endeavor and work on research on IoT. In this paper, you see, it starts with a particular code. So this is the overall picture of, let me Let me enlarge it. Let me enlarge it. See, in this paper, you see the picture. This one. I think it is a. You can see it, no? Can you see this paper? Can you see this paper on the other side? Is this paper is visible to you? Just anyone reply, please.
Yes, sir. It is visible, sir. Yes,
paper
sir.
is visible, no?
Yes, sir.
Okay. So you see this paper. Application domain of the independent services, real-time application, transportation. Ola Uber is making billions of money just by using IoT application, real-time application. Healthcare, still not matured, but it is going to be matured. It will play a prominent role over here. Agriculture, yes, I have seen it. I have seen it in Israel. Tomato, it is a, believe me, Israel is a barren place, desert. Rainfall is almost very, very little. They are producing two things. They first genetically modify particular vegetables or particular things so that they can be grown in a less water condition. And number two, they use IoT for sprinkling water, for sprinkling irrigation. Marvelous. And their tomato they are selling at 25 paisa per kg. What is the tomato kg in your place? 20 rupees like that. In Indian money, it is like that. A cabbage, 1 rupee, like that. Israel, a barren country, they are using IoT and some genetically modified seeds. They are doing miracle in agriculture. Some third is smart home. I am not in favor of it. Human being is already idle now, and if they become more idle, they will die very early by heart attack. Vehicles, yes, vehicle is, yeah. One of my students has given them this project. Why vehicle? I am driving a car. So all of a sudden, heart attack occurs to me, or I fainted. Heart attack has happened to me. I fainted. So what will happen? Before I actually die clinically, the car go and ram into somewhere and it will kill me by accident. Am I correct or not? So there is some provision in Audi car, Audi, A-U-D-I, Audi car, that if it feels, senses that particular man is unconscious or not in a position to drive the car, it will switch on to the automation. And in the automation mode, it can understand there in the road, there are some, in the road, there are some white strips are there. It follows the white strips. It follows the signals where there is a bending, and it follows the signal lamppost, red, green, and yellow. That things they understand. And using these they transmits to the cloud, and they get some sort of information, derive the information from into action, and they drive the car up to safety level. They go and at least they drive the car to the safety level, in the sense they will drive the car and park it somewhere, and immediately give SOS message to the nearest hospital or police station. This car is in danger. Please come and rescue. This is vehicle automation. Audi is using it. You see, I am telling you, there are cars which will cost you crores of rupees, 2 crores, 3 crores. Engine is not that much different. The difference in engine is there, but what is that? They are equipped with this type of IoT based instruments or all these things, which makes this car so much. It makes this car so much of useful, okay, and so much of costly. So if you can make this type of things and tell Maruti, go to Maruti that I will provide you this. I have made this, I will provide you this facility in your car. They will definitely take it from you. Scale up business. Schools, that means attendance, IoT-based attendance. Every student has got RFID. Whenever student enters into the class, I have seen it in the VIP, not VIP, VIP Misra, VIP Pilani. When they enter into the class, automatically their attendance is taken. But if some students are very smart to go through the back door, immediately that will also be recorded, and they will be not only marked, there will be warning letter will be issued to them online. The market, market is IoT based, supply demand based. That means some item is there, some item is not there, it is in shortage. So immediately they inform the next door, that means the main market, that it to supply over there. Industry automation is a very, very important area. There are several areas where human being cannot enter. So hot and so much, I will say, vicious is the place, and that human being may die. So in that case, we will go for automation. And automation with quality control can only be achieved through IoT. This is already there. A lot of robots are there. Lot of robots are used. This is already matured area. Don't try to venture into this area. You can venture into this Maruti car automation. Okay. You can venture into some sort of transportation. That means you can start a similar type of Ola Uber type things in your area if it is a, and you can go for agriculture also. So this is the application area of IoT. And I'm till now I was shouting IoT, IoT, IoT. Okay. Now after shouting IoT, 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 now I'm going to. So if you really go into IoT, the IoT which I have told you, the IoT which I have discussed, okay, IoT has got inherent problems. IoT system has got its inherent problem. What are the problems? What are the limitations of IoT? The limitations of IoT I have discussed on that day. Sorry. The limitations of IoT are scalability, self-organization, data volumes, interoperability, automatic discovery, security and privacy, fault tolerance, power supply. Power is, that means all the sensors are standalone sensors and having driven by battery. So its power consumption is very much limited. So its power is a very really a problem for all the IoT systems. Fault tolerance. Fault tolerance means gateways. Gateways, if there are, maybe for 100 people there is one gateway. If that gateway is got faulty, what will happen? In that case, the 100 people will be disconnected. Okay. Or even, so fault tolerance has to be there. Fault tolerance has to be. Some important messages passed from one place to another place, and one particular gateway is so by hopping. So one in between one particular gateway is spoiled. So whole line will be disrupted. The whole communication chain will be disrupted. So fault tolerance is really a problem for IoT. Security and privacy. This is a prominent thing. I have told you on that day. Security, because everything is done in, if you think of real-time IoT, if you think of the conventional IoT, everything is done in the cloud. Cloud is never a safe place. You can do your research in cloud. There is no problem. But you cannot think that bank properties, banks' information can be stored over there. You cannot imagine that a MNC is storing all its private, all its highly confidential data over there, which is their lifeline. No, they will not do it. Security, privacy is a dreaded issue for IoT. Even in my railways, I have told you one problem, commercialization. While I am going for commercialization, I have told you noise is my problem. But another problem is there. That is security. You see, there are open sensors on the line. There are so many open sensors on the lamppost, on the signal lamppost. Okay, if somebody may say some enemy country has came, just replaced it by some instrument, and which is giving faulty data, which is transmitting faulty data, which is actually not there. And that may cause devastation, that may cause accident also. So if my unit, which is there in outdoor care of God, if it is highly susceptible for attack, so if those things are changed by a pirated thing, or not only pirated, is given by a faulty system, that means it gives a wrong signal to wrong information, then there cannot be anything dangerous, more dangerous than that. There will be a lot of head-on collisions. There will be so many things will happen. So security and privacy, if you go with your, if you solve your noise problem and go with a coat and pant, and you tell the railway board that, you see, I have made such a beautiful thing, please take it. And after that, after one or two shots, they may take it. If you are a good orator, they will take it. But after one or two cases, when there will be this type of things are happening, so that means privacy breaching, that means replaced by some hostile notes, then they will not only throw it away, they will take you to jail also. So your first is security. And IoT security means you require a lot of computational work, real-time computational work. Computational work, any computational system is not afraid of. But here, it is a real-time systems. It has to be done in a very short possible time. So security systems, privacy system has to be given first, number one priority. Even if there is no problem, this problem will there. That's why bank is not using it. Automatic discovery. Automatic discovery means if you are using in a smart city, that means some new car has come from Lucknow to Delhi. It has to be connected automatically. It has to be connected without any problem. If the driver is not highly educated, so he cannot configure it to get it connected to the Delhi IoT systems. It has to discover, and it has to connect, and it I don't know how much heterogeneous network it is. It belongs to whatever network, whatever protocol it has got. Interoperability, same thing. Interoperability means requires common standards. So we use different sensors or different systems from different companies, and each company has got its own standard. So how to put them in a common platform. That means they say very common things. There are two types of interoperability. Interoperability means heterogeneity. There are two types of heterogeneity. One is data heterogeneity, and one is network heterogeneity. Network heterogeneity means common example. I am working with the GSM system, and another phone is working with the CDMS system. How to communicate between these two? How to get the data from them? And after getting the data, you have to send some signal to their particular language. So how to do it? Interoperability is a research issue. Data problem, big data. It's still a burning problem. Big data storing, processing, management is a really burning problem till now. Cloud, lot of research work is going on cloud. Jadavpur is doing hell of work. I'm getting so many this research citations, evaluation from Jadavpur who are concentrated on this particular area. This self-organizing, adaptation to the environment. Okay, adapt to the environment. Self-organizing means adapt to the environment means during daytime, I require a lot of communications are going on, so I require many numbers of what is called gateways. At night, I require very less, 2 or 3. Okay, because communication has stopped, human being is sleeping. So how to self-organize it? That means how to organize it, self-organize it. We have done it very nicely. I will show you. But if it is a gateway, for the gateway systems, you cannot. You can maximum what you can do. You can switch off some gateways. Okay, but their installation, their material cost is there. You cannot avoid it. But we have developed something. These gateways are softwares. So these softwares can be multiplied when required, and softwares can be deleted. That means that particular gateways are not there at all. Doesn't exist at all. We have done it. Soft gateways. Scalability. Scalability is another issue. All of a sudden, there is a massive traffic. Congestion will occur. Okay. So what will happen? That means you have to handle that issue also. So our system will work in that area. So what we have developed, I will discuss with you now. Scalability means all of a sudden there is a spike in the load. So you have to manage that scenario. And at night, of course, the things calms down to near about 0. So at that time, so you have to manage. So you don't require that much of resources. But how to design it? If you design it with respect to the peak load, then at night they are useless. You're wasting resources. Okay, and but if you if you make it with respect to the night one, then this cannot handle during the daytime load. So how to design it optimally? There are a lot of works has been done on it. Optimally means whatever optimality you achieve, that is a loss. But scalability, our thing which we have developed, I will discuss with you here. What we have done is that it is the software. That means whatever instruments, whatever switches, whatever controllers we require, automatically it will be multiplied, copied, and it will work. Start working. And whenever required, wherever required, it will start working. But scalability will, but when it's not required, it will just delete it. So these are the things which comes. IT has got its own disadvantage limitations. Its fault tolerance is poor, power supply is very poor, security privacy is poor, automatic discovery is also poor because of this limitation of the limitations of the resources. Interoperability naturally is also is very hard to achieve. Big data volumes are still a research work. Research stage. Self-organizing is also tough. Scalability is also tough. It involves a lot of money. Because industry means they will want something at less money. Industry means what? Industry means I will make a thing which will cost less, but which will give me more. This is industry. If you can satisfy this, you are king. If you cannot, destroy, perish. Next, implementation challenges of the high investment cost. That means you see, if you are going to implement these things with the IoT devices, it will always cost you very high investment. And next is security is definitely a issue. Data at rest, data in use, data in flights. These are the main three categories of data are there. You see, because here the bandwidth, I will say the speed of the data is also varies over here. Okay, many and IT platforms and the platform independence is also there. Many of the IT platforms consider security a core elements of the work and ensure that any potential leaks are stopped before the hackers find them. Okay, so the security is a big issue, and we have solved the security. I will show you how we have done it. And then technological infrastructure, communication infrastructure. Communication infrastructure is a really a problem. Communication infrastructure. While I am working with railway systems, I find it to be a very painful systems for me. But who has said me? LoRa has said LoRa type of things. I used in my previous first lecture, the first lecture of this particular session, I talked of various types of communication systems, ZigBee, then Bluetooth, then Z communications, LoRa. All these things I have talked to you. And LoRa is very good for type of long distance communications. And long distance communications are always preferred. So costly, but still it is. And this Bluetooth and Z and all these communications can be used for the benchtop models. If you want to get paper, you can use them. Everybody will love you. There is no problem here. But if you want to really use it, if you want to earn money, they will not help you anyway. They will make you your products impossible product. You cannot make anything using them. Okay. Next is immaturity of the IoT standardizations. Delhi is using some IoT standards made in China. Calcutta is using some IoT standards maybe made in Britain. Madras is some IoT standards made in Germany. There is no common platform, but mobile phone has got a common platform. All the mobile phones use some common because they are quite old and they are matured. Mobile phone systems are matured. They are using something very big. But IoT systems, since it is new and not yet much in use, except home automation and some sort of industrial automation, we are telling so many things we are using in hospital, we are using in industries. Believe me, very little utilization is done. Except USA who are doing it for the military. Really, they are doing it fantastically for their military. Military things are not achieved. You cannot get it. Military things It is not. You cannot patent it. Okay, and you cannot make a whole thing. Militaries never allow you to make a whole unit and give it to them. They will give you part of the product, and you don't know where it will be used. Naturally, for their security purpose. Okay, procuring IoT. So this is the problem. IoT architecture requires concurrent data collection, efficient data handling, connectivity and communications, scalable, security and availability and quality service. So this is very, very important. If whenever you make an architecture for a particular systems where you are going to use your things, these things has to be taken care of. Concurrent data collections. That means data are collected from different sources concurrently. Okay, if one data comes after half an hour, another data is coming. In that case, the information extracted will be wrong. Your information extraction process will be wrong. Okay, so information, you will get wrong information. So you cannot afford it. This is number one. This you have to ensure. Number two is efficient data handling. Data has to be stored, and you have to use a software which will give you real-time information extraction. Real-time information extraction. This is an AI tool. Okay, AI instrumentation. I think here you have to use best uses categorization, and then you have to use deep learning over here. You have to train your networks, deep learning networks for certain things, and after that, the things can be compatible to the real-time systems. Okay, connectivity and communication. Connectivity and communication is also very, very important thing. They may fail also, but I told you that whenever you design something, you prefer to take a long distance communications. LoRa is fantastic, I'm telling you. Achha. Then scalability. Scalability means you must see that you use less number of hardwares, more of softwares. You see, because in that case, what will happen, your cost of your product will be low, your flexibility will be very high. Scalable. Scalable means I'm increasing my resources. Calcutta is increasing. Delhi is increasing very fast. So how if whole Delhi is made this smart city? So that means you have to use lot of what is called gateways, install it everywhere, very costly, maintaining and all. It is a huge task. So scalability, instead of hardwares, if we can make something which in the cloud, I am using a lot of hardwares, lot of same things in software basis, so that these softwares can be, when required, it can be multiplied by copying, and when not required, it can be erased. So scalability is another problem which in real-time conventional ITs cannot do. Security, I have told you, is a problem. Availability and quality of service. Quality of service in IoT is variable. Availability means anytime, anywhere network. Anytime, anywhere network is availability. If it is designed like that, it will be able to provide availability. But in a case of ad hoc network, in case of ad hoc network, means where you are using it like railways, you are using it in defense areas, availability is really a problem. It is a research problem in the conventional IoT, and it is not easily achievable. And quality service means throughput, how many computations it does per minute, per second, and the packet drop, packet loss, and all these things, RTT, reverse round trip time. These are also the quality of services. This IoT is not that much good. Now, IoT architecture, it must be modular, flexible. Flexible means I can easily take one out. I can make one thing in platform independent. Of course, it has to be platform independent. Otherwise, heterogeneity will be, network heterogeneity can be handled. Open standard interoperability, it must operate the open standard. Device management, enable automated or device management. So, say you want to what are you doing? Anyway, so sorry for the interruption. Some family problems. Anyway, they follow project. So the open standard interpolations is there, device management and enables automated and remote. Say one particular sometimes see these gateways maybe their software may be upgraded. So there are in Delhi there are say 20,000 these gateways. So what happens if you have to upgrade the software for all of them? You have to send how many persons? At least 2,000 persons to upgrade it, or it will take long time to upgrade it. So it is a but on the contrary, if it can be done remotely, just sending some packets from here, as it is done in your computers, it will be so good. So device management should be remote and defined APIs. APIs help in the process. Each layer should be defined APIs should be there. And APIs that allow easy integration and existing applications with the integrated IoT solutions. Okay, next. I am coming into, this is already I have discussed last class. This now from here I am coming. This is the, now the question is you have seen and you have understood that limitations of IoT and you understood what we want. What should be our IoT architecture, so that I am discussing about some general IoT architectures, and you see these architectures very meticulously and you think you adapt them in your systems where you want to use them. That will be so beautiful adaptation, that will be so useful for you, for your purpose, for your business purpose, for developing your business purpose. These are the very something which I'll be discussing, which are not there, which you will not get in any textbook. Very little papers are available on this particular area, which I would like to share you, because I want that young boys and girls should start their business initiatives. Okay, rather than searching for job, they should be job provider. You see here, three-tier conventional architecture was like this. This is the old architecture. First, it was conceived in this way. This is the conception level. Perception, that means perception layers where sensors are there, network layers where this communications, all the communications are done, and applications layer where data storage and data analysis is done, and communication with the users are done. So this is IoT three-tier architecture. This is IoT three-tier architecture. It is like this. Next is you see here there are problems. All the problems which I have told you IoT are facing: availability, security, and reliability. All the issues are coming over here. So what they have done is in this way. They have for analysis. They have that means for increasing the reliability. You see, they have increasing the scalability, reliability. They have modified IoT into this type of figure. This is a paper of 2017 paper. Yes, probably by Sharma. No, it is not Sharma. Okay, so it is a paper, IEEE paper. See here, what they have done. Sensors are there in the sensors layer, device layers are there, and here instead of single gateways, they have constituted the gateways in a fog format. That means many gateways are topologically connected in a particular network topology to form a fog. That means what is the benefit of it? So if one gateway is out, if one gateway is spoiled, one gateway got defective, then other gateways can take care of it. Okay, this is number one. Number two, instead of single operation, I am working alone. If I am helped by you, my work will be done very fast. So in the normal conditions, they can share their load among themselves. So the fog gateways becomes very good operation in house. Okay, and this is the modifications they have done. This has increased their scalability to some extent, of course, and they have increased their energy part is not solved, but scalability is solved, and their reliability is to some extent solved. So this is one fog node for Lucknow. This is another fog node for Chennai. This is another fog node for Delhi, and all of them are connected through the internet to the cloud. cloud is distributed systems, and from there to the application layer, the data is stored, analyzed, and it has been communicated to the destination. And if after analyzing something, some actuator has to be energized, they again send it back to the fog node, and fog node communicates with the destined actuator. That is also possible. So this is the modification from the previous one, where this is the modification where only single nodes are used. Where only single nodes are used for single set of sensors. But here I'm using them in a cluster. Okay, so I am calling them flag or fog. So now fog-based architecture is one of the fog-based architecture is like this 2018 paper. The cloud environment. Cloud means Google in USA, and this is all the lands are connected to the one. Okay, and from there, and they are connected to the cloud systems, and they have just this is an application. You see here, everybody is connected. Standalone, dynamic, everybody. Even the cars are connected to the fog, and then they are connected to the cloud environment, and then they can operate. Okay. Now, what is more is there? You see, next architecture. This is the application part of this one. Next is that we thought that using this scalability part cannot be a scalability. Number one, scalability part. Number two is availability part cannot be increased. Security part cannot be increased. Okay, security part cannot be increased. So these three are still a roadblock to us. I can improve the conventional IoT up to the fog level, but still many problems remain. Many problems remain. Those problems needs to be solved. And using the existing architecture, I cannot solve it. So what we have done, we have looked into, myself and one of my research scholars, whose name is Rohit, we sit together and I told him to find out some other network structures. So which is like IoT. He then said with me with this SDN 3-tier architecture. SDN 3-tier architecture, he just told me, sir, this is very much similar to that. And SDN means software defined network. That means everything is software. So if I can replace those hardware-based gateways by the software-based controllers, then many of my problems will be solved. How they are working? See, in the infrastructure, there are 3 layers. Pure SDN. Infrastructure layer, control layer, and application layer. Infrastructure layers, there are network devices, the routers or switches, and access points. Any one of these can be there. Switches are there. Generally, we are using switches over there. But they are dumb. They are not inclusive. Infrastructure layer is not inclusive at all. They are like a post office. They get the data and send it to the control layer. Okay. No. They get the data, send it to the switches. Switches routes it to the destination. And if the switches fail to find the destination, then switches consult with the control layer. I'm not finding it in my domain. Kindly help me how to dispatch it. Control layer is basically it shows the route. It is used for route management purposes. Okay, so control layer has got many such infrastructure layers in their command. Then it finds out whether it can solve it, or otherwise it sends it to the upper hierarchy. But control layer there is a controller. In control layer, there is a controller which is a laptop or which may be a desktop like that, and very intelligent. Okay. Now, this infrastructure layer is connected to the control layer to the southbound API. Southbound API means OpenFlow or NetConf, etc. These are open source softwares available. You can use it. Okay. From the control layer, then after that, if it is to be sent to the cloud, then from the control layer through the northbound APIs Okay, it is sent to the application layer, so that means the clouds where application layer can from there this does the mobility management, access control, traffic security monitoring, energy monitoring. These all these things that can be done. Data is stored, and they can find the strategy for traffic security monitoring, energy efficient networking, and all these things are done from there. This is basically a SDN network, which is disjoint set. It is not connected to. It is not connected to IoT, but everything is in software. Control layer is a software. Application layer is of course a software. So I told him that if it is a software, control layer is a software. If I can replace the IoT systems or hybridize these systems with the IoT systems, many of my problem will go. Like scalability will go, availability will increase, security, since it is a desktop devices, we can our computational power, resource constraints to some extent removed. Okay, to some extent removed, and all these things. Many advantages I am getting from it. Now we started thinking how to push SDN, how to hybridize SDN architecture into the existing conventional IoT. So what we have done, sorry, what we have done is like this. What we have done is like this. See, now first of all, I told my student that if you go to a organization, if you go to a farm, or if you go to a factory and tell its manager that I have made a new type of IoT devices, which is SDN-based IoT devices, which will be more efficient than your existing one. So what you do, you throw away all of your systems, IoT-based systems, you just throw away in the dustbin. I'm installing my new one. They will also throw you out. Nobody would like to hamper its existing system in one shot, just listening to you. Even if you give them demo, even if it give you good results, if they show the good result, if it is not that much good, they will not take it. And I told him, try to install the SDN controller in your existing IoT framework. In your existing framework. See here, existing IoT framework is here. This is the sensors, the points, okay? And here is the cloud application frame. What Rohit has done, he has just simply put these things, open flow switch and SDN controller. He has put this thing. Just here, this is SDN controller is nothing but a laptop or a desktop, and the open flow switches are nothing but the Raspberry Pis. We have used Raspberry Pis. It can be ARM controller, it can be made easy. It can be in the commercial versions, it can be made cheaper also. So if I tell my customer, let your system be there, I am just installing these two devices into it, and I am just doing some software modifications. See that whether get improvement or not, they will take it. And he has exactly put it like this, and he got a miraculous good results. His throughput increases. We got a paper, of course. We have go for patenting here also. We got very good this thing, what is called RTT is improved. A lot of RTT improvement has occurred. Reverse round trip time. Packet loss is significantly improved. There is little one packet loss has there is very little packet loss, almost nil. Okay, and latency has improved like considerably. Then what happens? I told Rohit that you see there is only one SDN controller. If this SDN controller is out of order, then if this SDN controller is out of order, then the whole system will drop, whole system will fail, and then the CEO will beat you. So think something over here, how to do it. Because single SDN, anything single is a bottleneck. Don't do it. Then he has used multiple SDN controllers over here. Why? How? I'm showing you. What he has done is he has used multiple SDN controllers. You see here. Absorption layers, okay, and open flow switches, and this application layer. Previously there was only one controller. Now he has used, you see here, multiple controllers. He has used multiple controllers over there. Okay, IoT network. Same IoT network. having synchronous controller, which I have shown you. Believe me, performance level has here, this one single SDN controller, multiple controller is a heaven and hell difference. That's further improved, much improved. Because if any one of the controller is out of order, we got a paper here. We also applied for patent. If any one of the controller is got out of order, others take care of it. So reliability increases. Number two, these controllers are all softwares. They are not hardware devices. So I can increase the number of softwares. We have got a PC. In that PC, presently at night, 12 o'clock, I have got only one copy of the controller. Next day, noon 2:30, lot of traffic is coming. So what I will just make another various copies, say 100 copies. So there will be 100 multiple controllers, 100 controllers. So easily are configurable. Easily they can be configurable, and they can understand the load, and they increase the number of controllers in the system itself. How much beneficial it is. Even the open flow switches also you can install there, if possible. They are in one PC, and they can also be manipulated in this way. And the results is very good. I have told you, we have gone for patenting it. We have applied for patenting. Already complete specification has been submitted, and we are waiting for the result. And paper is already there, WPC. Now, next, after doing this, then we have come to the next version, 6-LoWPAN architecture. We have introduced 6-LoWPAN, is a very famous architecture, this IoT architecture, 6-LoWPAN. So there, what is my time? Up to 2:30, no? I think my time is up to 2:30, no? Yeah, maybe. So let me assume it is 2:30, and let me go ahead. So infrastructure layer, you see here, and 6-LoWPAN architecture. Also there, what is the infrastructure layer? That is location 1, location 2, nodes, sensor nodes are there, open flow switches are there, single controllers are there, and application layer is there. So I have replaced. I have introduced simply one what is called laptop, and where SDN controllers, they can be in one, they can be in multiple, and there is a core network there. That core network in the means many open flow switches in cascade in particular topological formations, and then the application layer is there. Okay, so this is another architecture we have developed. We have just introduced those things in 6-LoWPAN IoT architecture, and it is also working fantastic, much improvement than the conventional 6-LoWPAN IoT architecture. We have also published paper on it. Next, this is here where we get IEEE IoT paper here. See, all these papers, all these works, what we have done, everything, it's the bandwidth consumption. Bandwidth consumption is not reduced. Ultimately, everybody has to go through internet to the cloud. Here, it has to go to the cloud. It has to go from this here to cloud, and also in the 6-LoWPAN from this infrastructure to cloud, and again come from the cloud to the actuators, or maybe to the this one, or maybe to the user. See here, but here, bandwidth is also precious. Bandwidth is also precious. This is an architecture which we developed, and this is, of course, we have in a much advanced stage in patent, and it has been published in IEEE IoT journal, impact factor 9.7 probably. So you see what we have done. We have used multiple switches. So many sensors are there. You have seen so many sensors are there, and these sensors are connected. We have modified these switches. The switches which are available open source, we have modified. They are heterogeneous switches. They can take 802.4, and 0.11 also. But if anything comes, they can convert it into one format. And the red one is the controller. The red ones are the controllers. or you can say it is a single controller, or it can be a group of fork controllers. Red ones are fork controllers. They are all fork controllers. Edge controller. We call them as edge controllers. Now, what is the benefit of this? How it is save the bandwidth? So, if there is so this is network 1 is at Shillong, network 2 is Guwahati, network 3 is in Calcutta. So if there is a communication in Shillong itself, from one node to another, the switch can take part. The switch can, if the switch has got the routing table, they can do it. And if switch does not get it, it will communicate with the controller. The controller will modify its routing table, and as per that, the information can be routed to hopping techniques. So in that case, what will happen? Shillong can solve its problem in Shillong itself. It doesn't have to send it to the cloud. Okay, it is a two layer. This is a local layer. This is a global layer. This is in Delhi. This is in Delhi. Everything central, looking around all over India. Okay. Now, if Shillong wants to communicate with Calcutta, Shillong wants some data has to be communicated to Calcutta. What will happen? So it will not get, this controller will not get the address. This controller cannot solve the problem. Okay. So it doesn't have the address. This controller doesn't have the address for it. So what it does, that when it fails to get modify the routing table to help this particular network, one, to the whole network, that must be a set of switches in cascade, not in cascade, in a particular topological formation. They send it to global controllers at Delhi. 2 or 3 global controllers are there. They have got overview of all over India. So this controller sends the information to the global controller. See, I am failing to get this information. You kindly help us. They then they read it and they find it that this is Calcutta address. Then through the Buckles network, they send it to this controller. Okay, so that particular information has been sent from here to Buckles network to the global controller, and from global controller it comes over. And the global controller, sometimes data needs to be stored in the cloud or internet through the open source switches. It can be stored in the internet and or cloud, ThinkPads everywhere, and analysis can be done over here also. So similar things over here. So what happens, you see, instead of going to the cloud all the time, I'm solving it locally. So I am saving my bandwidth. And also my RTT, my packet drop, my latency is improved. Fantastic improvement. It's a remarkable improvement is achieved over here. And the heterogeneity is improved by just making these switches heterogeneous switches. Okay. So this is the network. It is really, we are proud of making this network. So this network we try to employ in railway systems. Okay, still I am far away from this. In commercializations, I am facing a lot of problems. To understand that from theory to simulation, fantastic, you will be excited. Theory to semi-theory, from theoretical, that means from simulation to semi-simulation, lot of pleasure it is working. Semi-simulation to benchtop, some problems you will face, but you will be enjoyed. I am getting, my things are done. I will earn a lot of money. No, after going into the field, you will see what is called work. The whole scenario will change. Next is this one I have already discussed. And now, blockchain based. When we are going for railways, it's blockchain based IoT, security. Blockchain based IoT, SDN based IoT, I will say. Blockchain based IoT means what? You see, I am using blockchain. You know, have you heard the name of Bitcoin? I think you have heard the name of Bitcoin. This is the Bitcoin is based on blockchain technology. Okay, so this blockchain technology, fantastic technology. It is a very good, based on the blockchain effort. a particular, a currency has been evoked. So how much imperviable is the technology is. Security is so good for that can be provided by blockchain system. Then we thought, why not to use blockchain system for railway security provision? That means if something has been changed by enemy or by some miscreants in some signal post, this technology, these security systems will immediately inform you that this has been changed, don't believe it. And immediately it will be reported back. And near the railway stations, near the railway this gumtis, there are many railway gumtis are there. Gumti, you understand? Gumti means there are 1 or 2 persons are there in the red buildings near about the railways. The gumtis are there. In these gumtis, this information is known that somebody has changed it, and some spare parts will be there. Those persons will come with the spare parts and replace it. So blockchain-based IoT, I will say blockchain-based SDN-based IoT. There will be 2 based. We have designed this architecture. We have designed it. Though in simulation it works nicely, but a lot of things we need to do. Actually, this incorporates this one also. This one also inside it. So how it has been done? You see, railway has got so many divisions. Railway has got so many divisions. Northeastern Railway, Eastern Railway, Southeastern Railway, like the South Central Railways. So many divisions are there. These hexagonals are the 7 divisions. And each division, there are sensors, and they are connected to the mainframe base station. That means each railways has got their headquarters. That is, Northeastern Frontier Railway has got a headquarters in Guwahati. Eastern Railway has got a headquarters in Calcutta. So there is a one node is one particular hexagon. One particular that means this one. This is one in Railway. This is Eastern Railway. This is Southeastern Railway, like that. So these are like this. This is now. What is security group? They are connected to a system of small computers. They are called miners. They actually do the blockchain calculations. Host of computers. Every node, thousands, crores of nodes are there, lakhs of nodes, crores are not there, of course, lakhs are there. So they take care of each and every component by blockchain technology. And when if something is wrong, immediately it is reported back to the headquarters, and headquarters immediately makes a phone call to the Gumti, go and do that. With that case. So, and this is central control. This is the control layer from the switch. The information, if the information is good, sun rises in the east, it is not information. Sun rises in the west is the information. Okay. So if everything is going normal, it is not passed over to the Delhi. If any abnormality is occurred, then and then only it is been confronted to Delhi. So this is the control layer for them. This is before going to Delhi. There may be many switches like this. So all these switches are again goes through. You see, there are second layer of blockchain before reaching the Delhi. First, they are forming this, and these switches, many switches are there. Such switches will be there, and because one switch cannot control so many information, there can be many switches in parallel, and which can be through this control layer again, through this blockchain filtration, because the switches can also be replaced. Enemies are there everywhere. You cannot believe anybody. Okay, so these switches are also monitored by this blockchain unit miners, and after monitoring, if they find nothing wrong, nothing abnormality, then it is go to the application that Delhi Railway Board. Okay, Delhi Railway Board, and also they resolve many issues. One is traffic issue, another is network issues. If there is any network issue anywhere, that is also reported to the railway board. This is blockchain-based IoT system, which we have developed, but still we are fighting with it. I am really not getting good students here. So really, if I can get good students from anywhere, I'll definitely jump into it. Good students. In research, good student means those got endurance. 99% perspiration, 1% intelligence in research. Okay. Next is, this is blockchain-based, SDN-based IoT. You see, 2017. This paper we have done 2016 end. This doesn't come in a good journal, of course. But in 2017, immediately we found one paper in IEEE. This is a Sharma. This PK Sharma is a small boy. He's from Assam. PK Sharma is from Tezpur University, Assam. And he has made so many things, so many good contributions in the SDN side. Okay. Okay. So this is what they have done. You see here, controllers, they have put them in fog. Okay. Blockchain is not applied there. They have not used blockchain there. All the blockchains are applied in the cloud. The cloud, they use certain area, and in those areas there are some defined computers, set of computers are working for them. There they have used the blockchain system so that their data is not stolen. Their data is not stolen. Okay. So they have used this paper. This is SDN-based fog IoT. One of the advanced paper. Okay, this is very much relevant to the banks, not for defense, banks of course. Now, I will show something for, I'll give you something for big data analysis. Big data analysis means, I'm telling you what is big data. I've told you about big data in case of war, Iraq, USA war. There are sensors, sensors means all the cameras are there, they are sending the photos, videos. Photos means what? Data is moving data. Data is with velocity. It's big data. Big data means lot of competition, huge competition. So big data is very much problematic. Big data is very much problematic. So what we do is that the architecture, we have made it. Though it is yet to be, one girl is doing it, lazy to the power infinity. Just here she has solved one thing. For big data analysis, two things has to be taken care of. One is heterogeneity removal, and another thing is making a algorithm, suitable algorithm, so that that means the computations can be done on the real-time basis. Very fast calculation, very fast computations has to be done. So you see here, for that reason, what we have done, and as well as security has to be maintained. See here, infrastructure there, camera, etc. there. Then network devices, LoRa, Wi-Fi, okay, everything is there, one, etc. there. IoT gateway, instead of gateway, we can use here switches. Then SDN controllers. These SDN controllers can provide the security, blockchain security for the lower systems. Okay, these blockchain controllers can provide the blockchain security for the lower devices. And this is cloud storage. After, if you once the storage, it is controllers' purpose is to give just that means it is to routing path. It is to assign the right path. That means flow table. Recalculate the flow table. Help in recalculate to devise the flow table for giving the routing systems. Then it goes to the cloud storage, and from the outflow storage, what they do for the first calculation, they use Hadoop, big data, Apache Storm, and Apache Spark. They use this type of software in the cloud. In the application there, they are using it and getting the information instantaneously and doing the problem. So what she has done, she has get the data in centimeter and and in London is doing in FPS, India is doing in CGS. They have sent it over there through SDN controller. It is stored in the cloud, and here she has used semantics, and from here, using the semantics, she has heterogeneity removal she has done, but but he has not gone up to the level of what is called big data analysis. Okay, this Hadoop etc. He has not done. What are the problems in it? I will go to the problem. Actually, this is the generalized architecture, and actually her architecture is detailed architecture is this. Her detailed architecture is this one. I am giving you everything. I'm not putting it because I am from IIT. I don't believe in hiding any information. Hiding information is done by idiots. You share information, you will be at risk. Okay, I don't believe it. By hiding information. Information is so much. We know nothing with respect to the information which we need to know. Okay, so you see how this is the much more detailed smart home vehicle transportation system, e-health services. E-health services, that means the operation part is also there. Weather forecast system, this is too much, and that means it is satellite pictures. So aggregator point 1, aggregator point 2, they just post office, they send it, they map it over there, the data processing unit. Okay, so data processing unit, yeah. In between, he has put a data processing unit, map reduce using, okay, and real-time data lookups or tables are sometimes used for fastness, okay, and then it goes over the application layer. Basically, we are using here unsupervised clustering techniques first, and then we put it into some known deep learned networks, and where I will see that whether this thing is lorry, this is a bus, this is a taxi, or what is what, those things. Some defined things we like to do it because after all, this is a PhD work. She is not going to do anything else, and really I will not take any dog with me. We are not working at all. So application level is here. Application level, high level events. This is the application level where unique decisions, other things are carried on over here. So you see here. So what is required everywhere, you see it is given here. Intermediate layer, what is given. Vision modules are there. These are all deep learned networks. Okay. So this is the architectures. This is where this architecture can be used. These architectures can be used in the battlefield, or this not in the battlefield. These architectures can be highly used in the if you use cameras in the border areas, they can be used. Okay, but the sensors which I have told you for border security, there this is not used. There this is not that much security. Of course, because they are actually what they are doing, they are catching some radiations, and they are analyzing the radiation. That is also analyzing the radiation means you have to do what is called this Fourier transform, online Fourier transform, instantaneously, because otherwise that enemy will fly. If you take 2 minutes to analyze it, yeah, that enemy will just run away from that place. Okay, the terrorist will run away from that place. So what we have to do? We have to do it instantaneously. Yeah, a human being is entering. Please take care. So it is like that only. So this is all as a must. And now I have told you this is some application area building. I have discussed these things in my first lecture. How if there is a disaster, if there is a fire in a high-rise building, so the sensors, fire sensors will sense where there are fires, and it will point out to the panicky residents which directions they will leave the place, so that minimum casualty or no casualty occurs. If there is an accident in the road, in the highway, both of them has died, say. So who will report it? This is the IoT systems which will help you to get the ambulance, to get the police, everybody. Emergency response. This is emergency response team is very important for Shillong. During rainy season, we say in Shillong that two things are very dangerous. One is sky and another is hill. because a lot of landslides occur at that time. So if emergency response means if there is a landslide and if it is automatically being reported to them, or if it has been predicted and told to them that this may happen now, they could have been ready over there with the instruments and they could stop it to some extent. Okay, they can prevent the loss to some extent. Okay, so this is the thing. Now, number 2 is, I told you, this is also I have told you in the last day. This is landslide detection, and this is also reverse. That means flood monitoring systems. Okay, flood monitoring systems you can make. I have got an order from them. This one I have got order. This landslide from Nagaland government. They say, and Mizoram government, they say this is a menace for them. If we can help them, I'm saying that whether you can do it, because this now this is very much not possible because we are under lockdown, and last 1 year we cannot work at all. If the student force doesn't come, who will work? Okay, so this is another thing. Thank you. But before thank you, I would like to show you something from my paper. Yeah, from another paper. You please read this paper. You see, the paper is so good. I am just showing you in a very much in a nutshell. So first it has discussed about the architecture, the application areas. Next, it has discussed the market opportunity. Okay, what are the different market opportunities? Then IoT architectures. It has discussed about architectures. So already I have discussed what each layer means. What are the each so what is the each layer means? They have it has discussed here, and all the layers they have discussed separately, which I have already told you. And this is IoT means identification, sensing, that one is means sensors, communications means identification means which set of sensors data has to be taken. Sensing means its value. Communications means it is transmitted. Computations means in the cloud, these sensing data are analyzed. Then services to be provided. Then what is to be done? That goes to the actuator. And semantics means if this data that is, say, the humidity data is coming in some unit, temperature data is come some other unit, those has to be resolved. The semantics does that. Semantics does that. So this is your thing. Now, but when I'm going into this, just I'm showing you in a nutshell so that it becomes easy reading for you. See here, these are the ways. Ways is very important. Tiny ways, Kentucky, light ways, Raptors, and Android. Okay, can you see this thing? Now? Can you see this paper? Please, somebody responds. Can you see this paper?
Yes, sir.
Huh? Yeah.
Yes, sir.
Yeah,
Yes, sir.
Okay. Tiny ways,
Yes,
Kentucky,
sir.
light. Okay, thank you. Right ways, Android. These are the very important things which, but they are not applicable to our systems. We are working with Open Daylight, RU, and Open Daylight resources, RU, and Floodlight. So this is for my system. Means SDN-based IoT, they are not valid. This is for pure conventional IoT. But you see here, the communication, it can be done. Identifications with IPv4, IPv6, like this, sensing, smart sensors, communication, RFID, NFC, this I have already discussed, BLE, IEEE 802.15.4, Z-Wave, Wi-Fi, LoRa, and Wi-Fi Direct, etc. Computational hardware. This Raspberry Pi is very important. And another thing, I have said modes. Modes, I am not getting it. This Spanish company is not responding. I don't know what happened to them. Software, there are a lot of sorts of ways, tiny ways. These things already I have told you, but this is for say Hadoop is also used for big data problems, big data analysis. And services, what are the services available? Shipping, information aggregation, smart grid, for a smart home, EBS computing, and semantics analysis, RDF, OWL, and EXI. RDF and OWL we have what? EXI we have not worked with. The next is Next is services, etc. These things, whatever I told you is there. Semantics also you need. IoT command standards. Yeah, see here. These are the very table 3. Application protocol in the application layer. POP. I use POP. This is COAP. MQTT also you use. MQTTSR also we have used. Okay, and REST also we have used. These so DTS and others we have not used, but this I have always used. And service discovery, DNSSD, this is not required for us in benchtop model. And then routing protocols, RPL, and we have used 6LoWPAN, and IPv6 also we have used sometimes, and 102.15.4 and also 0.11 also we have used. And I told you that we have made a switch which can use both of them, where both of them is accessible. Okay, so these are the protocol stack. This is very useful for you. Okay, this is to be very carefully to understand how to design application protocols or the POP, etc. So next is you see, these are all application layer things, how they are working. This you have to read and understand, because in this 2 hours lecture, everything is not possible to discuss in it. Just I'm showing you because so that you can read it, you can explore it, you can use it for your own purpose. In Israel, I have found the professors are very rich person. Like here, our businessmen are rich. Their businessmen are rich. Along with them, professors are also rich because they develop something, and government immediately give them money to set up their own factory. And if they can run the factory, fine. If they cannot run the factory, some big company comes and take it, give them good price to purchase it from them. So they are very rich because their aim is to develop something, not to write a paper. Only paper. Paper writing is, of course, it is required. But only paper writing a paper for paper writing sake, they don't do. They don't believe in that also. So anyway, so these are the different characteristics of different physical layer protocols, LPA, ZA, BAE. These are the just specification levels, nothing else. And finally, okay, reliability, availability. These are how they are solved, how they can be removed. This is written in the context of only IoT, conventional IoT, not in our IoT. So if you read it, you can understand very much what are the constraints of the present IoT systems. And then if you go into our SDN-based IoT systems, you'll find that many of the problems are worked on. Many of the problems are worked on very comfortably. And you can develop it also. Now we are thinking of putting ICN-based IoT. ICN-based IoT. ICN means information-centric network-based IoT into it. And we are replacing, trying to replace blockchain by Chia. But Chia is very good recent software for security. These things I told you, see, the application domain, network, this is sensors are there, they are giving to the servers, and one doctor and few nurses are there, they are taking care of everyone. They are getting data continuously in the server, and the server sometimes give the warning, and even doctors can see all the data, and if you find something wrong, he will rush to it. So hospital managements become easy with fewer staff, because doctors are trained. And in the corona, a lot of doctors are dying also. You know, in a Delhi, you see there are 10,000 bed hospital. So how they are running? They are running by this one. Anyway, so these are the references. So I will send this paper to Lalit sir. If you are interested, of course, if you inform him that you require this paper, then only I will send it. Otherwise, unnecessarily, I will not send it. And if you give me information that sir, the students are working or these participants are interested about this, then only I will send it. Otherwise, no. Okay. Thank you so much. Thank you so much. Now the time is 2:28. If you can ask me some questions, if you have some question, your question will enrich me also. You can show it.
Participant, any questions from your side?
your questions will enrich me also.
Participants, any question?
One wants to know the title of the paper.
Which paper?
One participant in his text message, he wanted to know the title of the paper.
Which paper? My paper or this paper?
Yeah, your paper, Sir.
Okay, I will send the whole paper to you because it's already been published.
Right, sir.
I'll send the whole paper to Lalit sir, and he will discuss.
Right, sir. Then I'll put it on Google Classroom.
Any question? Okay, sir, I think there is no question from the participant side. Thank you for very thought-provoking and your informative talk, sir. I would like to, on the behalf of Department of Computer Science and IT,
Amit, just a minute before you finally formally close.
Okay.
Professor Gautam Saha,
Yes, sir.
very good afternoon.
Very good afternoon, sir.
I was listening to your lecture, very wonderful talk and a lot in detail. I think, and most of our participants were very interestingly attentively listening to you.
Yeah.
So thank you very much for all your good lectures and very interesting talks for this program.
Yeah.
Thank you.
Sir, only one thing I will request you at the end, that
Ji.
if you find any good student and if you want to work with us, I'll be so happy. Good students, not everybody. If you find a really good and intelligent and hardworking students, and if you think that you will work with us, I am ready to work with you.
We can certainly do that. Yes, some of our students who are really interested in working in these areas, so we can think and we can discuss about it. Yes, that will be wonderful, sir. That will be wonderful.
Thank you.
Thank you.
Thank you, sir. Thank you so much, sir.
Thank you so much, sir.
Thank you so much, sir. Thank you.
Thank you. Okay, participants, we will meet again at 3 p.m. sharp.
Okay.
Okay.
Okay,
Thank you.
bye.
Thank you, sir. Thank you.